Problem number 3.3 from Irodov from Electrodynamics. In this problem, it is given that two small equally charged spheres of each of mass m are separated, are suspended from the same point by silk threads of length L. The distance between the spheres x less than L. Find the rate dq with respect to dt with which the charge leaks off each sphere if their approach velocity varies as v equal to a divided by root x, where a is the constant. Now for solving this question, this is the arrangement for our problem. There are two spheres a and b which are hanging by two threads of equal length L. So this is the length of the threads L, and this is the support. As it is given that mass of each ball or each sphere is m, so its weight mg will act downward. This makes total angle 2 theta, so its angle, half angle, will be theta by 2. So here the angle will be theta by 2, and in this side it will be also be theta by 2. Let the tension developed in the string or thread is equal to T. So if we divide this T into two components, then this component will be, as this angle is theta, this angle is theta divided by 2, so this component will be T cos theta by 2, and this component will be T sin theta by 2, T sin theta divided by 2, and there will be a force of electrostatic force, that means Fe force, and in this direction there will be another force which is called, so charge of the sphere is q, and in this direction there will be a force of gravitation Fg. So this is our arrangement for the related problem. So all the arrangement in the problem is shown in figure. So for equilibrium of a sphere A, for equilibrium of a sphere A, the net force on the sphere is 0. The net force on a sphere A is equal to 0. So forces acting on the sphere A are forces acting on a sphere A. The sphere A are classified into few categories. The first force is electrostatic force, which is Fe equal to 1 divided by 4 pi epsilon naught q square, means q into q, it means q square divided by x square, and its direction is along BA. Means B, it is directed in the direction from B to A. And second force is gravitational force of interaction. Gravitational force of interaction between spheres, which is equal to Fg, and Fg is equal to Gmm, means Gm square divided by r square, if r is the distance between them, and its direction is along AB, means A to B. Now third force is weight of the spheres. Weight of sphere A. Now weight of sphere A is W equal to mg, which is downward, acting downward. Which is acting downward. And fourth force is the force of tension T. Force of tension T. Now for equilibrium of a sphere, A, for equilibrium of a sphere A, we can write equilibrium condition is summation of Fx, means force in all the direction acting in x direction is equal to 0, and second summation of all the forces acting in y direction is 0. That means Fy is equal to 0. So these are two conditions. So from the first condition we can find Fx from summation of Fx equal to 0, which implies that Fe is equal to Fg plus T sine theta divided by 2, because here is the direction Fe and Fg is directed in this direction. Fe equal to Fg plus T sine theta by 2. And from the equilibrium condition, summation of Fy equal to 0, it implies T cos theta by 2 equal to mg. T cos theta by 2 is equal to mg. But force due to gravity Fg is less than Fe. So we can neglect this gravitational force. After neglecting, or we can say Fg approaches to 0. So from our equation, if we neglect Fg, then our equation will become T sine theta equal to T sine theta divided by 2 will be equal to Fe. Let this is our equation number 1. And for equilibrium condition in y direction, it will be T cos theta by 2, which is equal to mg. So let this is our equation number 2. Now if we divide these two equations, dividing equation 1 by equation 2, which implies T sine theta divided by 2 divided by T cos theta divided by 2 is equal to Fe divided by mg. Or we can cancel this T and T from this side. If we cancel this T and T, we will get tan theta by 2, which will be equal to Fe equal to 1 by 4 pi epsilon naught into q square divided by mg. Now according to the geometry of the figure, according to the geometry of the figure, sin theta by 2 equal to x divided by 2l, because here if we take this angle, sin theta by 2 will be equal to x divided by 2l. Or since x less than L, so if x less than L, then we can write here sin theta by 2 sine theta by 2 will be approximately equal to theta by 2, which is again approximately equal to tan theta by 2, equal to x divided by 2l. Now this, if we can replace this equation number 3, let this is our equation number 3, we can replace the value of tan theta by 2 from equation number 4 to equation number 3. So if we replace this value, then we can get x divided by 2l will be equal to 1 divided by or q square divided by 4 pi epsilon naught mg. Or from this equation we can write this x cube and there is x square also, mg x square is there. So x cube, you can write here from this equation, x cube equal to q square l divided by 2 pi epsilon naught mg. And again from this equation we can write q square is equal to 2 pi epsilon naught mg x cube divided by l, or we can find the value of q as it will be equal to under root, value of q will be under root 2 pi epsilon naught mg x cube divided by l. So this is our equation number 5 and this is our equation number 6. Now from equation number 5 we can write x cube equal to q square l divided by 2 pi epsilon naught mg. If we derivative or differentiate both sides with respect to t, then we'll get d dt of x cube will be equal to d dt of q square l divided by 2 pi epsilon naught mg, and this will be again equal to l divided by 2 pi epsilon naught mg into d dt of q square. So from this equation we can write the derivative of 3x square will be x cube will be 3x square dx with respect to dt, and that will be equal to l divided by 2 pi epsilon naught mg, and derivative of q square will be 2q into dq with respect to dt. Now we will replace the value dx with respect to dt as v. So we can write 3x square into v will be equal to l divided by 2 pi epsilon naught mg multiplied by 2q into dq with respect to dt. So in the next step, so we can write from this equation this 2 and 2 will get cancelled. If we cancel this term, then we can write 3 divided by 2 x square v will be equal to l divided by 2 pi epsilon naught mg into, now if we substitute the value of q from equation number 6, because from equation number 6 we already got the value of q, so if you substitute that value, then we can write 2 pi epsilon naught mg x cube divided by l instead of q, and again this is multiplied by dq with respect to dt. Now as we know, in our given question it is given that the velocity varies v equal to a divided by root x, so we can replace the v as a divided by root x. So we can write 3 divided by 2 x square into A divided by root x will be equal to under root L divided by 2 pi epsilon naught mg x to the power 3 divided by 2 into dq with respect to dt. Because it is given here v varies in the relation a divided by root x. So from this equation we can write the rate of leaking of charge dq with respect to dt will be equal to 3 divided by 2 a under root 2 pi epsilon naught mg divided by L. So this is our required result for finding the rate of leakage of charges from the sphere.